Welcome to clickmyproject.com. Now I'm going to explain Semantic-Aware metadata organization paradigm in next generation file system. This paper is under the domain of data mining. What is data mining? Data mining is the process that attempts to discover patterns in large dataset. It utilizes methods at the intersection of artificial intelligence, machine learning, statistics, and database systems. The overall goal of the data mining process is to extract information from a dataset and transform it into an understandable structure for further use. Data mining consists of 5 major elements. First one, extract, transform, and load transaction data onto the data warehouse system. Second, the store and manage the data in a multidimensional database system. Third, to provide data access to business analytics and information technology professionals. Fourth, analyze the data by application software. Fifth one, present the data in a useful format such as a graph or table. Now I'm going to explain abstract of the paper. A novel decentralized semantic-aware metadata technology is called Smart Store. The idea of Smart Store is to limit the search scope of a complex metadata query to a single or a minimal number of semantically correlated groups and avoid or alleviate brute force search in the entire system. The Smart Store is used to improve the system scalability and reduce query latency for complex queries. It is also conducive to constructive semantic-aware caching and conventional file name-based point query. Now we're going to explain brief concept of the paper. The next generation large-scale storage systems new metadata organization schemes are designed to meet two critical goals. One, to serve a large number of concurrent access with low latency, and second one, to provide flexible input-output interfaces to allow users to perform advanced metadata queries such as range, top-K queries to further decrease query latency. In existing, the data storage system based on the hierarchical directory organization is used. The data storage system is scaling up rapidly, a very large scale file system. The storage system contains thousands of server nodes, trillions of files, and reaches exabyte data volume. But many disadvantages are there. First one, the distributed database failed to achieve efficient management of petabytes of data and thousands of concurrent requests. Next, the file system only provides file name based interface and allow users to query a given file, which severely limits the flexibility. And also the problem of scalability. In proposed, novelty of Smart Store lies in its matches actual data distribution and physical layout with their logical semantic correlation, so that a complex query can be successfully served within one or small number of storage units. The Smart Store can very efficiently support complex queries such as range and top-K queries, which will likely become increasingly important in the next generation file systems. A semantical grouping method is proposed to effectively identify files that are correlated in the physical attributes or behavioral attributes. Smart Store support complex query services and improve system performance by exploiting semantic correlation of file metadata and efficiently utilizing semantic analysis tools. For example, latent semantic indexing. It can avoid these disadvantages in terms of file organization and query efficiency. Additionally and importantly, the Smart Store is able to provide the existing services of conventional file systems while supporting new complex query services with high reliability and scalability. Our Smart Store system can support 3 query interfaces for point, range, and top-K queries. Conventional query schemes in small-scale file systems are often concerned with file name-based queries, and it will be efficient and effective in next-generation large-scale distributed file systems. The complex queries will serve as an important portal or browser, like the web or web browser for internet and city map for tourists, for query services in a version of files. Now we are going to explain system architecture of the paper. The datasets are loaded into project. These datasets are first applied to a clustering process. The similar type of data are clustered, each one of the cluster to form a document. Next process is to form a entry in each document. Next, to apply the Smart Store system. Inside Smart Store, the Bloom filter technique is applied. In Bloom filter, any document is extracted. The extracting document is inserted into Bloom filter. Next is to apply Bloom process. In Bloom process, the search or deleting process are to be done. If user to choose search, the searching result is to be displayed. Now I'm going to explain demo for project. First, start WAM server because the data are retrieved from databases. To open Addons, to run load.java form. In that form, to click load, the data are to be displayed in the table. The first 100 records are displayed, and next 200 records are displayed, next 200 records are displayed here. And click cluster. The new form is open. And click cluster. The data sets are clustered according to country wise. The result of the cluster is to form a documents. These documents are to be shown in tree structure. If you want to view any one of the document, choose any one document and click view. The particular documents to be shown. If you modify this document, choose any one of the file. To add some contents and click modify. These contents to be appended into the document. To view the modification, to click view. The appended document to be displayed and click Bloom. Next form is opened. To click extract. The total documents are extracted. Choose any number of documents. I will choose one document. This document to be inserted into Bloom filter and click process. The next form is open. There are two types of searching are done. First one character based, second one is string based. I search a string according to country ID. If any one type, choose country based and type any one country and click string. So this particular record is present in Bloom filter. So the CHN and the country wise records are to be displayed. Next, I search a character according to name wise. Click character. So the particular records contains H related words. Next click delete. The next form is open. Here the deleting done is according to record wise or particular value wise. I choose particular value and give one string and click delete. The successfully delete particular value is to be message to be displayed and click view. So the particular value is to be deleted. Next I choose record. To give any one of the string, I give this string and click delete. So successfully deleted record. The message is displayed. Click OK and click view. So the particular record is to be deleted. Finally, I conclude this project. The smart store is highly scalable and can be deployed in a large scale distributed storage system with a large number of storage units. And smart store is used to reduce query latency over database approaches. Thanks for listening.